All righty. So, hello everybody. Welcome to the TST meeting after a several-week hiatus here. And today, Jordan Hotterman is going to present with us some updates on the distributed systems as well as ISSU. So, go ahead, Jordan.
All right. So, yeah, like Thomas said, I'm here to pretty much give an update on recent work that's been done on the distributed systems in ONOS and also work towards ISSU. So I'm pretty much going to go over a review of our past discussions. So a few months ago, I was in here with a number of distributed systems proposals, which I'm going to follow up on here. And then, so after a review of the past discussions, talk about the actual work that's been done, how ISSU fits into this work, and future work that's planned for the upcoming week. And so the goals I want to get out of this are, I just want to inform people of what's changed, why it's changed, what we hope to get out of it, and like I said, what's next. So a short review of how I think about ONOS's distributed architecture. So I sort of think of it in layers, like going from top to bottom, top being lowest layer. These aren't necessarily in the correct order, but roughly, we sort of have like cluster management, messaging, failure detection. On top of that, the RAF consensus protocol, partitioned RAF clusters, additional protocols, and then of course, primitives and the actual stores that use the primitives. And the reason I'm showing this is because what I've sort of been doing since I've been here is going sort of from the lowest level up, working from the lowest level up, working on fixing architectural issues and trying to improve stability. And so sort of the phase that we're in right now is doing the RAF protocol, and up next is going to be partitioning, improvements to partitioning and scaling and things like that, which I'll get to. And so I'll talk about, I'll go over some of the architectural flaws that I discussed last time I was here in the RAF implementation and how they were fixed. So going to those proposals that I went over last time I was here. Some of the things I brought up were, really there were two major themes. So I was sort of looked at it from the perspective of the stability of the distributed systems, the stability of the RAF implementation, and then after that, the actual maintenance of code. So first up, so some of the things I talked about that I had found were issues in the actual RAF implementation, which was copycat, where that copycat was really not well designed for the use case of primitives, where each primitive inside of ONOS uses separate state machines, and really copycat was designed around the idea of a single state machine, and that was really that. In testing, I really started to notice that was sort of limiting performance and harming the stability of the system overall, just because in reality, on a single node, there's tons of different applications using tons of different primitives, and the architecture of copycat sort of implicitly links them all together. And so we saw this start to cause like lots of cascading failures and things like that, and really it limited performance by limiting concurrency. And so, like I said, I thought significant performance improvements could be achieved by treating primitives as separate units in terms of consistency. So, like I said, the second thing that I talked about last time was the actual code. And this has been an idea that has been around for a long time, I know. Obviously, a lot of the distributed systems components inside of ONOS are incredibly useful outside of ONOS, so I wanted to start moving them out of ONOS into separate projects. And so, like, essentially anything that is a distributed systems component that would be useful on its own, I think should be moved out. The primitives, clustering, messaging, things like that.
Quick question. Do you envision merging that into Copycat, or is it creating a separate project for that? Kind of, so you have Atomix, Copycat, and then something else, or?
I don't have any strong opinions on it right now. Right now, I envision it being Atomix just because it has a user base, and it's a lot closer to what it says it wants to provide. I mean, so
makes sense. Okay, that's good.
Yeah, I mean, and a lot of ONOS's internal distributed systems components really align with what the long-term goals of Atomix were, anyways. Perfect. So it's really good as a version 2. And so those were the two sort of proposals that I came with last time. Since then, we added a sort of additional requirement of ISSU. So ISSU is inter software upgrades, and essentially the goal of this project is to be able to upgrade clusters without any downtime. And so sort of core to the whole ISSU process is the idea of cross-version compatible serialization, where to upgrade an ONOS node in a manner that it can communicate with nodes that are still running an older version, we have to use sort of version serialization. And there are a number of ways of doing this. There are a lot better. There are like protobuf and a bunch of serialization formats that support schema evolution and things. But the thought around this was that we don't want to do anything too crazy. There's a lot of low-level work that needs to be done to be able to support a version serialization framework anyways. So we didn't want to have to go through the process of totally replacing. Right now we use CRI-O. CRI-O has a version field serializer that does something very similar to what the other more well-known version serializers do. So the thought was that we should just use that for the first iteration of this. The problem is that in order to support CRI-O in those low-level distributed systems components in the Raft implementation, the Raft implementation does like a lot of custom binary serialization, things like that. So it took pretty major refactoring to be able to get to a point where we could use CRI-O at that low of a level. And so the need for ISSU sort of drove the need to do all this refactoring in the short term, because, and the reason is it shows it right here. I said refactor now or deal with upgrade paths later. So the problem is, some of this refactoring that I proposed deals with like on disk serialization formats and things like that. So one of the refactoring proposals was rewriting the Raft log in a manner that was more efficient. So if we were to release a version of ONOS that supported ISSU and then did that refactoring later, that would mean that later when we do that refactoring, we also have to figure out how to deal with files that are on disk in the old format and convert them to the new format. And so that's a bunch of added development overhead in the future that can be totally eliminated by just hurrying up and doing the parts of the refactoring that needed to get done or that would be impacted by ISSU ahead of time. And so sort of the goal to support ISSU drove the timeline for a lot of the refactoring. So I decided to take on, like I said, at least the refactoring that would be affected by upgrades. So what were the goals of refactoring? So goals of refactoring are, as I see them, to create a more stable cluster that can run quote unquote forever, and that's where ISSU fits in. And like I said before, better performance in parallel applications, better encapsulation across applications, and more testable and more maintainable components. So a lot of these goals are to address deficiencies that I saw in testing over the first few months that I was here, really, and maintaining code over the first few months.
Question, what do you mean by encapsulation? Sorry, brother.
Yeah, so like I was saying before, I said Copycat was not well designed for the primitive use case. What I mean by that specifically is that each node, essentially right now, or before this refactoring, each node had a single session, a single Raft session to communicate with the Raft cluster for each partition. And the problem with that is consistency guarantees are sort of provided within the context of a Raft session. And so the problem is a primitive that's running in one application, if its consistency guarantees are broken and it starts seeing timeouts, all the other primitives in the other applications see timeouts. So what we saw a lot in testing was cascading timeouts and cascading failures and stuff. If there's some failure, just like one lost message could cause timeouts in all of the primitives.
So this basically, I think what you meant by this was better isolation between applications.
Yeah, sure, yeah. So how did I go about meeting these goals? So like I said, one of the things that needed to get done before ISSU was re-architecting the Raft log. So that log had been written a long time ago and was really inefficient for the Raft use case. So essentially it built indexes for all the entries in the log, and so it held in-memory indexes. But the thing that I realized was Raft inherently reads and writes logs sequentially. It always appends to the end of logs, always reads from the beginning of a log to the end. So there's totally no reason for having to build an index, and it was just wasted memory and wasted CPU. And the other interesting thing that I realized was that Raft guarantees sort of they can give you lock-free concurrency. So Raft guarantees that, essentially the way Raft works, without giving a tutorial on this, is a change is sent to a leader, the leader appends it to a log, the leader replicates it, and then the leader commits it. And the thing is that once an entry is committed to the log, Raft guarantees that it won't be lost. And so that gives you sort of lock-free concurrency, where anything that reads the log before the last commit index can assume that nothing is ever going to write it. So you don't need any locks to read. And so that helped improve concurrency and performance in the Raft implementation. And so like I was saying, Copycat was poorly designed for the primitive use case. So state machines and Atomics' Raft implementation are redesigned for primitives, where Atomics creates a separate state machine for each primitive, which increases concurrency in the server because it doesn't have to enforce order across all the primitives inside the server. And then another thing that I mentioned earlier was there was a lot of complexity in primitive state machines. So one of the things that Copycat did was it had a sort of complex log compaction algorithm that required state machines to participate in the log compaction algorithm. Anyways, so that was replaced by snapshotting, which is a lot simpler. Essentially, state machines inside the Raft cluster just write out their state to disk. And so that simplified a lot of the primitive state machines inside of Onus and makes them easier to test. And then, like I was saying, primitive clients. So this was really the big thing. This was one of the big pieces of the refactoring that I thought would affect stability the most, which, like I said, we saw cascading timeouts. And so the Raft implementation was refactored to allow for multiple sessions per client. So now what you'll see is, rather than, like I said, all of the primitives sharing the same session, each primitive has a separate session, which means separate consistency guarantees, which means they order requests separately, and there's massively increased parallelism, and timeout in one primitive won't affect any other primitive at all. And then the second big point of instability, which I haven't mentioned that I often saw in tests, was there was a lot of complexity in the Raft implementation in managing connections between clients and servers. A lot of the times with the timeouts that we saw were caused by clients trying to find a server to communicate with and setting up connections, meanwhile request timed out. And then similarly, we also saw performance inconsistencies where clients would sometimes connect to followers or sometimes connect to servers, and requests were proxied in a sort of inconsistent manner to the leader, and that caused really inconsistent performance. So that was addressed by discouraging proxying. And then finally, for ISSU, this was all the stuff that needed to be done for ISSU. So Raft logs that are actually written on disk are now written with version information, so that if we ever do need to make changes to the Raft log format, we can just write a new reader or have multiple readers that understand different versions of the log format. Serialization was entirely removed from the Raft implementation, so now it's really just a function call. And so this allows ONOS's own serializer to be used inside of the Atomics Raft implementation. And then on that front, the CRI-O code inside of ONOS was updated to, when ISSU is enabled, use CRI-O's version field serializer or compatible field serializer. And the compatible field serializer allows backwards and forwards compatibility by serializing field names. So what does all this mean? So what this means is with the serialization changes, now ONOS nodes can share state across versions when ISSU is enabled. We don't have multiple versions of the software to run right now, but when we do, so after the Loon release, thereafter you should be able to replace Loon release nodes with M release nodes.
In theory, you should be able to run it between the different betas of ONOS, right?
Yeah.
For the Loon release.
Yeah.
You should probably try that.
Sure. Yes, I know. Yeah, and there's a lot of, and there's the next big thing to do is testing this stuff.
Yep.
And it's more stable. So I mean, a lot of the refactoring that was forced by ISSU was to fix all the instability issues that I've seen testing throughout my time here, which are mostly timeouts, trouble with large clusters. And so this morning I was able to run 20 iterations of the HA cluster restart test with the topology running, 20 iterations of the smoke test on a 9-node cluster, which I couldn't even do one time before. And so even though there's a lot more work to do before the next release to make sure that this upgrade is stable, the architecture has already proven to be a lot more stable to me, I think.
This is great. So this will be available as part of the beta, right? It's all already ready to go.
Yeah, I updated it today.
So it'd be awesome to see if Sienna could run their smoke tests on the beta version as well.
Yeah, that would be great. Yeah, and I mean, my ultimate goal is ONOS should never see timeouts unless a loss of availability occurs. I mean, I see them all the time in just running FTC. And really, we should never see them unless you're killing more than a majority of nodes. Yeah. Any questions?
This is great.
So what's next? So we've had various conversations about what's next. I think none of this is really surprising. So I think as we sort of work through and make sure this stuff is more and more stable, I think the next thing, and John and I were talking about this earlier, is dynamic clustering. That sort of seems like the next thing that's doesn't feel real stable quite yet. And the other piece of that is repartitioning. And I sort of see these three things as being one. So ISSU goes with dynamic clustering and repartitioning because, as I see it, the ability to upgrade your cluster and run it forever isn't very useful if you can't add nodes to it and you can't scale the partitions.
Right.
So these are, I think those are two things that we need to seriously consider handling in the next release. And then on top of that, just continuing disaggregation, which will be a slow process. There's not really any rush, but yeah, eventually we'll get there. And that's it.
This is great. So with respect, so do you think there is any value in, in testing the existing clustering mechanism? So Ray is currently working on sort of enhancing the facilities that Morad originally put in place to dole out the cluster JSON.
Yeah.
And there's some more work to be done, right? To be able to properly generate and evolve the partitioning scheme. Do you think there's still value in doing that?
I think we should.
In this release and stressing that potentially even via JSON, sort of via STC?
Yes.
Okay.
Yeah, I mean, I think we should. I think we're going on a really good path. I think several people have been playing with the dynamic clustering thing, and it's sort of pushing things along at a good pace, I think. So, yeah, I mean, the existing dynamic clustering stuff is the path that we want to go on.
We've effectively had it for almost 2 years now, right? Well, no, not 2 years. 1.5 years.
Yeah,
because we demoed it at ONS.
The previous one.
Not this one, but not this past one, the one before that, right? But it requires sort of
It was sort of
a lot of hand-holding and manual management of the cluster JSON, which is why I was interested in having at least some sort of a full-man's tool to be able to manage that.
Yeah, if we put, like I said, I think all these things go together, and in order to be able to sell ISSU, we should be able to sell dynamic clustering as reliable things that don't just work sometimes.
I definitely see those as related too, yeah, because especially there's really not much value, and there's some, but there's only a diminished value in the dynamic clustering if you can't repartition.
Right. Yeah. Totally. Yeah. I mean, if you add 10 nodes to a 3-node cluster with 3 partitions.
Yeah. Exactly. Yeah.
Yeah. I mean, I think we're still most of the way there, so it shouldn't take too much if we just put a little bit of effort into it. I think these are huge assets.
This is great. In terms of, quick question, in terms of sort of the community help, I mean, we have an ISSU brigade, right? But that one is sort of in a nascent sort of a startup mode, right?
Yep.
Predominant amount of work is done by you, right?
Yep.
Is there any possibility for community to come in and help?
Yeah, so our goal,
areas?
I talked to David yesterday about, recently about that, and so our thought is that we should be trying to get people involved after the L release, in the M release. So I do have thoughts about ISSU specifically. My concern, it can't be a one-man job, because my concern is that the maintenance burden goes up over time, because a lot of the cost of supporting ISSU is going to be in managing changes to stores.
Exactly. Yes.
As we do more and more refactoring, there's more and more upgrade paths that have to be accounted for, and there's also other things like currently there are even small things that can break ISSU right now. Adding a type to a serializer in the middle of the order of the classes will change their serialization IDs, and it'll totally break upgrades. So I think we need help from the community to try to deal with those things and find some solution for either finding a better solution for handling the serialization itself, or a process for preventing those types of changes.
Kind of like validation, right? Almost.
Yeah.
Yeah.
So yeah, and I'm also just interested in stakeholders getting their thoughts on ISSU also. their input on it.
And right now, we're at the point where we can make changes to the model objects, right? That are
Yep.
presented, and this we done with the cross version. If we were to try and change the stores, then
Yeah.
we need to be careful about how we do that.
Right. Yeah, so there's ongoing work on ISSU to provide a way for a version to change how the state is stored. Like, let's say you have some store that was storing data in a map, and it changes it and stores it in a set. When that node is upgraded, the state also has, or when the cluster is upgraded, the state also has to be upgraded. So we need additional APIs to say that an upgrade happens, and additional code to say, read the old map and write it into the new set, and things like that. So it's going to be an ongoing maintenance.
Stores definitely will have to do their share of the burden of guaranteeing the ISSU functionality.
Yeah.
They can completely change the implementation underneath it, and only they are the ones who are aware of what were the structures before and what are the structures now.
Yeah, and then obviously what we need is really good testing to ensure that things don't break ISSU.
Yeah.
In order to be able to say that it's supported.
Yeah. Well, certainly, I mean, the work that you're doing right now is essential, right, because it sort of paves the way for the work above on the higher layers to occur. But without it, there would be no point. If by simply adding a field to some model object, you're going to break the whole thing, then what's the point? You can upgrade as long as the two are the same.
Yeah.
Oh, this is great, Jordan. Thanks. All right, I like it. Good progress. Any questions, comments?
When you see a partition of the second from the bottom, that's actually partition of the
Oh, no, yeah. So I should have formatted this more correctly, but I was
Data
talking about moving the partitioning into atomic, moving primitives into atomic. I was being lazy when I made this.
This is great. Any questions, suggestions, concerns? Very nice. Thank you, Jordan. Would you mind sharing this document with me, and I'll post it? Is it on Open Networking or ONLab?
Open networking.
Perfect. So
So,
share that link with me, and I'll link it up to the TST page and to the video. So we're only about halfway through our hour. So is there any other topics people want to discuss or bring up? If not, then you can just call it half hour back. And, all right. Well, now that you is here, I think we can call it a day. All right. See you next week. Next week, somebody else may need to run it because I have a meeting. All right. So I'll arrange that. So bye, everybody.